right, today we're going to talk about section 8.1, which is dealing with ratios and proportions. First off, we need to talk about what is a ratio and a proportion. A ratio is a relationship between two numbers. And it is expressed in a couple different ways. It can be expressed as a fraction, or a to b, in a couple different ways. And as far as a proportion is two ratios set equal to each other. We'll be using the proportions throughout this chapter with the various properties. The first one is the means extremes theorem, and it's a proportion in which the product of the means is equal to the product of the extremes. The means are B and C in this case, and the extremes are A and D. And that's the order in which you list them. So the first term listed here is the A, and then the second term is the B, and that will be used later on when we talk about setting up a proportion. In number 1, for example, it says find the fourth proportional term. So these are the first three terms of the proportion, so you have to set them up as the first term 2 over the second term 3 is equal to the third term 6 over, we don't know the fourth term in the proportion. And now that we have it set up, we can go ahead and solve for x. So the fourth proportional term in those set numbers is 9. The next example, when we're trying to find the ratio of x to y, what it is equal to, we're trying to find out what x over y is equal to, what ratio it is equal to in this case. So first off, we need to look at this problem that we have and try to get it manipulated to get it set up like that. So first off, when we cross multiply, we can get 5x is equal to 21y. When we want it to get to be x over y, if we divided by y to get it to be x over y on this side, and then over here we wanted to get rid of the 5. So the y's would cancel over here, the 5's would cancel on the left side, and we have x over y is equal to 21 over 5. So when you go back to that first part, when you have 5x equals 21y, you're trying to see what exactly it needs to be as far as a ratio on the right side in order for it to be x over y. Very similar type of problem in number 3. But first off, in order to do that, in order to isolate the x, we need to get the x's on the exact same side. So we need to manipulate this one by moving the ax to the other side, and then adding the 4y to the other side. So now we have the x terms on the left side and the y terms on the right side. Now, in order to get x over y, we need to isolate each one on each variable on each side. So we're going to factor out the x on the left and factor out the y on the right. And now that we have them factored out, we can set up x over y by dividing by y to the left side, and then dividing by 2 minus a. Find out what the ratio of x to y is equal to. In the next problem, it's talking about an equilateral triangle, so we know that all the sides are the same. And then it also says that m and n are midpoints. So if we know that this whole side is the same, and then we have the midpoints. We know that all four of these sides are the same. So when we're talking about finding the ratio of these sides, we don't really care what the actual measures are. We don't need numbers. We can find out in a ratio what AM is to BN. We know that whatever the values are, they are the exact same value. Therefore, the ratio of those sides is 1 to 1. And as far as number 5 is concerned, we're talking about the ratio of AM to BC. Again, we don't know what the measures of the sides are, but we know that AM is half of BC. So AM is 1 in a ratio of 1 to 2 of BC. For the next couple examples, we're talking about arithmetic mean, which is also known as the average, and you guys know how to do that when we take the sum of the numbers and we divide by how many numbers there are. And when you're talking about the geometric mean, which is also known as the mean proportional between two numbers, you set up a proportion between two numbers, and these numbers will be given to you, and then you are solving for the geometric mean. And remember, the mean numbers are these middle two numbers, B and C here. So we're finding those numbers in this particular problem. So we're looking for this one, and it's the same number. So we would cross multiply and find out that x squared equals whatever those numbers are that they are giving you in that particular problem. So if we look at number 6, the arithmetic mean means that we just add 3 and 27, and there are two total numbers. We find out that the arithmetic mean is 15. As far as the geometric mean, it tells us that it's between 3 and 27. So those are our extreme numbers in the proportion. And we're solving for the geometric mean. So what number goes in both of those mean spots in order to satisfy the proportion? So you can get x squared is equal to 81. And when we solve, we get that x should equal positive or negative 9. In number 7, it tells you that 8 is the mean proportional. So when you set up our proportion, it tells us that 8 is that mean number. And it tells you that your numbers that it's between is 12 and you don't know, so we're going to solve for that other number. Same thing, we will cross multiply. And when we solve for x, we get 16 thirds. In the last example, it's very important that we read and understand what the question is actually asking. The 20.5 centimeter Toblerone bar is cut into two parts in a ratio of 4 to 3. How much longer is the longer part than the shorter part? Well, first off, we have to take the bar, which is 20.5 centimeters long, and to cut it up into two parts. And they're in a ratio of 4 to 3. So we'll divide it up into two parts, 4x and 3x. We can then solve for the value of x. And when we divide by 7, we find out that x is equal to 41 over 14. Now that just tells us what x is. We still don't know how much each part is, so we can substitute x in and find out that the 4x part is 82 over 7, and the 3x part is 123 over 14. And then we want to know how much longer this longer part is, so we can subtract the two and find out that is 41 over 14. centimeters longer. And that concludes section 8.1.